Right, in this video, we are going to talk about how to simulate chance behavior. Before we do that, let's talk about hiring discrimination. An airline has just finished training 25 pilots, 15 men and 2 women, to become captains. Unfortunately, there are only 8 captains positions available. So the airline decides to hold a lottery to choose the new captains. The names of all 25 candidates will be put on equal-sized pieces of paper, mixed well in a hat, and then 8 will be drawn. The airline reports the results of the lottery as 5 women and 3 men were chosen. Some of the male pilots believe the drawing was not carried out fairly. The question seems to be, is it believable that these results happened by chance? We can use a simulation to answer that question. Is it reasonable that it came out that way? Okay. So let's first talk about how to perform a simulation. We're going to use the 4-step process that we've talked about many times. State, plan, do, and conclude. And if you need to pause to get this written down, you certainly can. But state, we're going to ask a question about a chance process. And then our plan, we're going to describe how we're going to use a chance device like random integer or equal-sized pieces of paper as a chance device. Table D, to imitate the process. And then we're going to tell what we would record at the end of each trial. Do, we're going to perform many repetitions of the simulation, and then finally our conclusion, we're going to use the results to answer the question. Okay? Alright, so let's determine, was this airline's lottery fair? So the first thing we want to do, we want to state the question. Okay. In a lottery, supposedly fair, right? In a fair lottery, supposedly fair lottery, okay, of 15 men and 10 women, is a result of 5 women and 3 men being chosen reasonable. 5 women is that reasonable? Okay. Our plan. Now we could do this various ways. We could say that number, we're going to have 1 through 15 are going to represent the men, and 11 through 25 would represent the women, and then we use random integer to pick the numbers. That would certainly be okay. Okay. But since they already used a chance process and what they said they did it on equal-sized piece of paper, and that's an easy one to simulate. So let's use their chance process to simulate their chance process. So we put the numbers, we'll put the numbers 1 through 25 on equal-sized pieces of paper. One through 15 are the men, and 16 through 25 are the women. Okay. And you could do that the other way. You could have 1 through 10 be the women and 11 through 25 be the men. It doesn't matter. Okay. We will mix well in a hat. And draw 8. Record the number of women chosen each time, each trial. Because we're really interested in is 5 women when more than half the applicants were men, only 3 men were chosen and 5 women were chosen. Okay. So we want to know. Now do. Repeat the process many times, the simulation many times. And that could be 20 times, 30 times, but many times. And conclude. Using the results, we will determine if 5 or more women, because it could be more, right? Women being chosen in this scenario is unusual. So we're looking to see if it's statistically significant, which of course we know statistically significant means not likely to happen by random chance. So we want to know, was this likely to happen by random chance or not? Was it statistically significant or not? Good. All right. At their annual picnic, 18 math students in the math statistics department at a university decide to play a softball game. 12 of the 18 students are math majors and 6 are stat majors. To divide into 2 teams, one of the professors put all the players' names in a hat and drew out 9 players to form one team. With the remaining 9 players forming the other team, the players were surprised when one team was made up entirely of math majors. Is it possible that the names weren't adequately mixed in the hat, or could this have happened by chance? Design and carry out a simulation to answer these questions. Well, it would be very similar to the last one. We would have our state, they state it for us. Okay. Basically, we want to state something similar to that. Okay. In a pool of 18 students, 12 math majors, 6 stats majors, is it reasonable for one team to be made up of 9 math majors when 2 teams are chosen randomly? Okay. Now our plan put math on 12 equal size pieces of paper, and stats on 6 also equal sized. Both groups be equal sized. Okay. So both groups have equal size, so all 18 pieces of paper are the same size. Okay. Draw out 9 after mixing well in a hat. Those 9 become team 1. Okay. The remaining 9 are team 2. Record the number of math majors on each team. Okay, so it would do, so repeat many times, right? Repeat many times. And our conclusion would be count the number of times, or number of trials in which one team was made up of 9 math majors, if the percentage is high, we don't consider it unusual. If it's low, then it's an oddity. And that's how we're going to do that. Okay?